Matter of this neutron star will consist of pure neutrons. According to Walter and Zwicky, after the supernova explodes, a neutron star is formed and its diameter will be only about 10 to 20 kilometers, very small. However, the mass of this neutron star is predicted to be larger than the Sun. This shows that the neutron star has an extremely high density and such an extremely strong gravitational force. Walter and Zwicky predicted the theory of the existence of neutron stars after a supernova explosion. However, the hypothesis of these two scientists was too advanced for the time because neutrons were only discovered in 1932, so the concept of a celestial body made entirely of neutrons was not accepted by the scientific community. At that time, furthermore, the two also predicted that the sound neutrons they theorized would not emit light like other normal celestial bodies. This meant that searching for neutron stars with telescopes was very difficult, and therefore it was impossible to prove the existence of neutron stars through observation. So the hypothesis of Walter and Zwicky remained a pure theory. The hypothesis of the two was forgotten because there was no evidence until the 1960s. After that, many scientists predicted that neutron stars would exist super-fast spinning. Pula. However, until the 1960s, scientists had not found any signs of sound neutrons. At that time, astronomers were studying quasars, the brightest and most energetic objects in the universe. At that time, they were developing methods to measure the position of quasars more accurately. Anthony Hush, an astronomer at Cambridge University, was also one of the researchers of quasars. He and his graduate student, Jocelyn Burnell, worked at the Mullard Radio Observatory in Cambridge. At this time, Burnell, under the guidance of Professor Hush, was responsible for operating the telescope and analyzing the data. She analyzed about 29 million of data every day. About 2 months after starting to analyze the data on August 6, 1967, she discovered a radio signal repeating regularly with a distance of 1.33 b-seconds. However, this signal did not come from the Earth. It was always emitted from the same location outside the Earth and not a telescope error or an instrument error. This was clearly a signal coming from space, and it appeared regularly with a distance of 1.33 b-seconds. The two people hoped that this signal could come from an alien civilization, but they also thought that it could be. This was a natural phenomenon in the universe, and they continued to investigate with all possibilities. They joked that this signal was alien and nicknamed it Little Green Man on December 21, 1967. The two people discovered a second signal with almost the same characteristics. Finding a second signal that was almost identical showed that this was not a signal from an alien civilization, but a natural phenomenon. There was also research by other scientists. In 1968, Richard Lovelace's team observed the center of the Crab Nebula using the Ray-C-B Observatory and discovered a pusa at the center of the nebula. This pusa rotates with a period of 33 marches, an extremely fast speed. In 1933, Walter and Zwicky predicted the theory that after the supernova explosion, a neutron star would remain. They classified the rapidly rotating neutron star as pusa. Thanks to the work of Huey Wish Burnell and Lovelace's research group, the existence of pusa, which was only a theory, has been completely proven. The scientists who predicted the existence of sound neutrons and pusa by just theory and calculation were amazing, and the scientists who actually observed them were also amazing. Anthony was awarded the Nobel Prize in Physics for discovering pusa. However, Jocelyn Bell Burnell, who operated the telescope and analyzed the data to discover pusa, was disqualified from the prize. Many astronomers, including Fred Ho, criticized Byrne for not being chosen as a co-author of the prize. Why was her work so underrated? Was it because she was a woman that she was not awarded the Nobel Prize? Or because she was just a graduate student? Any way she played a key role not awarding her is unreasonable. On the other hand, some people think that no matter how important her role is, the direction of research is still decided by Professor Highwis on this issue. Burnell expressed that she did not feel resentful for not receiving the Nobel Prize, but even respected the decision of the Nobel Committee. Fortunately, thanks to her active research activities, later she received many prestigious awards such as the Oppenheimer Prize, the Herschel Medal of the Royal Astronomical Society, the Tinsley Prize of the American Astronomical Society, and was knighted by the Queen of England. Later, Burnell said that instead of the Nobel Prize, she received many other awards and had the opportunity to attend many parties. That is also good. Really a great example we have learned about the story of astronomers, theoretical prediction, and successful observation of the existence of pulsar. Now we will learn about pulsar in detail, starting from how they are formed. Imagine there is a star with mass 1 to 8 times the size of the Sun. This star gradually evolves into a red giant and then a white dwarf. Take our Sun as an example. In about 5 billion years, the Sun will become a red giant. At that time, the Sun will swell up to more than 100 times larger than it is now, swallowing about Mercury, Venus, and finally the Earth. After becoming a red giant and swelling up, the Sun will carry out a nuclear fusion reaction with helium as fuel. When the helium is burned out, the outer shell will be pushed into space, leaving only the central core, which is the white dwarf. Our Sun will become a white dwarf in about 5 to 7 billion years, with a diameter of about 13 to 15,000 kilometers, equivalent to the size of the Earth, or slightly larger in volume. The Sun will shrink 1,000,000 times when becoming a white dwarf. It is amazing that a giant star like the Sun can become so small. So what about a star with a